Good afternoon, everyone. My name is Priya Pandey. I am Assistant Professor of IIMT College of Pharmacy, Greater Noida. And today's topic, we're going to discuss about colloidal dispersion, which comes under the Physical Pharmaceutics Subjects, PP 403T. Okay. In today's video lecture, we're going to discuss about what is colloidal dispersion, basically introduction, then classification of dispersed phase, general characteristic, what are the general characteristics of colloidal dispersion, and how the size and shape of the colloidal dispersion. According to size and shape, we're going to also discuss about classification and comparative properties of colloidal dispersion. Right. And lastly, we're going to discuss about conservation and peptidization. And that's all. In this unit, we're going to discuss all these things, right? Firstly, when we heard about the colloidal dispersion, basically what is colloidal dispersion? Right. It is kind of that thing that it is a heterogeneous mixture. It is a heterogeneous system which consists dispersed phase and dispersion medium, when in which particle size of dispersed phase ranges from 1 nanometer to 1 micrometer. Right. Either we can say that in this colloidal system, the dispersion where the internal phase is entirely dispersed through the particle are distributed in uniformly in in the dispersion medium, and the particle size range may vary from the 1 nanometer to 1 micron as well. Right. The colloidal system in this colloidal system are passes through filter paper, but not passes through the semi-permeable membrane. In some cases, it diffuses very slowly also. Classification of this in this in this topic, there I want to add some more colloidal system, some more definition on it. That is, what is molecular dispersion and what is coarse dispersion as well. Basically, colloidal system, colloidal, molecular, and coarse dispersion are basically, it is the three of them is like a heterogeneous system, but the size range of dispersed phase or dispersion, size of dispersion in which particles are dispersed, right? The size of that dispersed molecular ranges differently. And in molecular dispersion, the dispersion in which the particle size is less than 1 nanometer, that's known as molecular dispersion. In case of porous dispersion, the dispersion size of particle or the dispersed size of particles are vary from it may be greater than from 0.5 to 0.5 micrometer, right? For example, gelatin, acacia, and rubber. Classification. Colloidal system encountered in pharmacy, that is the class. If we thoroughly talked about the classification of colloidal system, it is basically divided in depending on the size and shape of colloidal particles. It is basically divided in three categories, that is molecular dispersion, colloidal dispersion, and coarse dispersion as well. As I already said, that molecular size in molecular dispersion, the size of particle in case of molecular dispersion is less than 1 nanometer, right? And it is, they are not the size of dispersed medium. If the size of dispersed molecule or dispersion molecule is less than 1 nanometer, it comes under molecular dispersion, right? And as we know that they are invisible in electron microscopy because the size is very less, right? Yeah. And they can pass through the ultra filter and the semi-permeable membrane. For example, glucose, oxygen molecules, and ordinary ions as well. In colloidal dispersion, the size particle of in this colloidal dispersion is formed like 1 nanometer to 0.5 micrometer, and it can be detected under the ultra microscope. Basically, they can pass through the filter paper but does not cross the semi-permeable membrane. They diffuses very slowly, as we know, and the final example of this, like shaving cream, paints, and etc. Coarse dispersion, the particle size will be higher, and the size will be like greater than 0.5 micrometer, and they are visible under the microscope, and then do not pass through the filter paper as well as the semi-permeable membrane, and they diffuses very slowly, or they did not diffuse in any medium. For example, grains of seed and most of the emulsion and suspension are comes under this kind of coarse dispersion. What are the application of colloids? If we talk about the therapy in colloidal system, are or it is a therapeutic agents as well. In case of that, that mean in example, silver colloid, germicidal copper colloid, anti-cancer microbial colloid is that kind of therapy when it is basically it is from this kind of the from this kind of colloid, so we can easily target the therapeutic agent, and also in our body, it shows pharmacokinetic as well as pharmacodynamic activities as well as in our body as next. Absorption as a colloidal dimension, all are small through the have huge surfactant, hence the drug constituted colloidal from its release in a large amount. That means the target in case of targeted drug delivery, liposomes of colloidal dimension are very preferentially taken up in liver and spine as well. Right. And as we already discussed, the classification of dispersed system, basically depending on the size and shape of this classification, we can boldly classify the dispersed system, basically dispersed system in three categories, right? Firstly, basically, what it matters the dispersed phase and the dispersed medium. Dispersed phase is that kind of phase which consists of that particulate of the material, right, or particulate of the metal. It distributed throughout the continuous phase, and the continuous phase is also known as dispersion medium. They are classified depending on the size of that particular dispersion or dispersion matter or particulate matter. It is basically divided in three categories. That is molecular dispersion, which I already discussed with you, which is less than 1 nanometer. If the molecule or if the particle of molecular dispersion is less than 1 nanometer, that is known as molecular dispersion. If the size of particle of colloidal dispersion is in between 1 nanometer to 5 micrometer, that is known as colloidal dispersion. And in case of coarse dispersion, the size vary and it may be greater than 0.5 micrometer as well. Okay. In case of colloidal dispersion, the size, depending on the size, I already highlighted it that the size will be 1 nanometer to 0.5 micrometer, right? The particles are in microscopic vigilance. It is easily detected by the ultramicroscope, and they can passes through the filter paper, but where they face problem that they did not cross the semi-permeable membrane. Now, for example, for example, colloidal silver solution, or natural or synthetic polymers. In daily life, for example, we can take example of paint, milk, or shaving cream as well. They diffuses, but the diffuses slowly. Okay. For the chorus dispersion, the particles are visible under the ordinary microscope because on the size. Because the particle, the size of the particle is greater than zero point 0.5 micrometer, and they are visible. That is why they are visible under the ordinary microscope as well. They did not pass through the filter paper, and it does not dilute it or dilyse through the semi-permeable membrane, and it is not diffused in any medium. Right? For example, emulsions, suspensions, and red blood cell as well. Next, the characteristics of the dispersed phase, particle size. The particle size, basically, this influence the color of the dispersion. Wavelength, if we talk about the wavelength of the light, basically it absorbs small wavelength, and the vector of the, if we talk about the alpha 1 divided by radius, that the radius, if in case of large wavelength, it is called visual wavelength, and in case of small wavelength, it is calculated by the lambda 1 equals to 1 upon radius. The particle shape depends on the preparation of method. We can and the affinity of dispersed medium. How can it dispersed medium will diffuses in the dispersion medium? It influences the colors of dispersion as well. And through this also, the shape and size of the dispersion medium also affected. Like the particle, the shape of colloidal particle is also important. On the extent of the particle and specific surface also get increases, therefore they will greater because they will the greater opportunity to attract force and establish the particles of the dispersed phase and dispersion medium as well. Other properties such as flow property, sedimentation, osmotic pressure are also affect the changing of the colloidal particles, right? And the particle shape is also related to the pharmacological action as well. The particle shape may be vary from the sphere, globules, rods, short rods, and threads like iposomal branch threads, etc., etc. The surface area, in case of surface area, the particle size small or large surface area effectively enhance the solubility and effectively enhance the catalyzer as well. As we already know, the particle size, small particle size has larger surface area, and the medium or large particle size had the tendency of small surface area, and it also affect the pharmacological activity. For example, absorption, the ADME also affected by this surface area as well, or if the particle size well is right. Classification classification depending on the nature of interaction between the dispersed medium and dispersion phase. Colloids can be classified in lipophilic, lipophobic, and association. Basically, based on the nature of interaction, based on the dispersed phase, dispersion medium, molecular in dispersed phase, appearance of colloid and electrical charge, all the things is basically classified the colloids in three categories, that is lyophilic colloid, which are like liquid loving colloid, lyophobic colloid, which are liquid hating colloid, and lastly association of colloid, yeah, or amphiphilic colloid, which is basically has the tendency of both. Lyophilic colloid, in this lyophilic, the term consists of lyo and philic. Basically, lyo means liquid and philic means loving. If the dispersed phase interact with a great extent with the dispersion medium, then the colloid called lyophilic colloid. If the dispersion medium is water, then they are called hydrophilic colloid. If the dispersion medium is non-aqueous or organic solvent, then we call it as a lipophilic colloid. Lyophilic colloid are thermodynamically stable, and therefore they have difficult to coagulate. They can be radially reconstituted by the simple mixing, And they are also called intrinsic colloid, for example, rubber, protein, starch. Basically, we have to understand in this kind of colloidal solution, the dispersed phase has greater extent or greater affinity through the dispersion medium, right? And it can be easily, because it is a liquid loving dispersed phase, it can easily dissolve with the dispersion medium. Right. And it is thermodynamically, if we talk about thermodynamic stability, it easily is stable in thermodynamically, it is stable, and it is reconstituted by the simple mixing as well. For example, starch and rubber, protein. And next is lyophobic colloid. Lyophobic. In case of lyophobic colloid, what is lyophobic? The lyophobic means, the lyo means liquid, as we already know, and phobic means hating. Right? They are hence, like we can say, they are liquid hating colloids. If the dispersed phase has little or no affinity to interact with the dispersion medium, then the colloid is called lyophobic colloid. They are also thermodynamically unstable, and it requires a solubilizing agent for their preservation. They are also known as extrinsic colloid. For example, souls of metal like silver, gold, or souls of metallic hydroxide are the example of this kind of colloid, right? In this, for lyophobic colloid, they are difficult to prepare, and this requires some special method for the preparation. They are prepared by the dispersion medium and as well as the condensation method also. We like in next lecture we're going to discuss about what is dispersion medium and what is condensation method. Lastly, Lastly, we are we'd also discuss that last one colloid, that is associated colloid or associated colloid. Basically, this colloid have behave as a normal electrolyte at the lower concentration, but in it behaves also as like in so behave as at higher concentration. At associate colloid, it also refers as a mistral. They are also considered as amphiphilic colloid. At low concentration, the amphiphils are exit separately. As the concentration increases, the agitation occurs over the narrow concentration range, and this agitation is also called as missile. Right? They consist of two group like hydrophilic. The head group is hydrophilic, that is water loving consistency, and the tail may be in hydrophobic, right? That is water hating consistency. At the concentration at which missiles begin to form, that is known as critical missile concentration, that is in CMC. Below the CMC, the surface active agent undergoes absorption of air and water interface. With increasing concentration of surfactant, molecules get accumulated at the interface. At the point where the both interface and bulk phase become saturated, that is CMC. In case of beyond CMC, the bulk phase appears, and therefore the energy system is reduced. Okay, that is for example, the CMC. For example, we can take the example of associate colloid or amphiphilic colloid soap, right? And like polyethylene oxide are the example of associated colloid as well. In multimolecular colloid, the individual particles are dispersed consist of agitated atoms or small molecules having diameter less than 10 to 7 centimeter. The particles are held by weak, like agitated or captured weak van der Waals balls. For example, gold salt, sulfur salt, macromolecular colloid are that kind of colloid. The particle dispersed sufficiently large and enough of colloidal solution, and this is also called as natural polymers as well. For example, starch, cellulose, protein. Basically, in this video lecture, we discussed what is colloid, what are the introduction of colloid, and what are the basic characteristics of colloid, and why where the application of colloid, and the effect of colloid in for the pharmaceutical formulation. Thank you for listening. Have a good day.